Hello guys and welcome to another video. Today I'm going to walk you through step by step on how to prove all the laws in logarithm. Stick to this video till the end because at the end of it all, I'm going to give you one particular law that is different from the normal laws that we know. Without further ado, let's get right into it. In fact, this right here is the first law, which is log base a of x plus log base a of y is equal to log base a x y. Why? Here's the deal. First things first, I'm going to set this guy to m. So we will have log base a of x is equal to m. Then this guy right here, I'm going to set it to n, which will be log base a of y is equal to n. And guess what? We are saying that log is the inverse of a certain exponential function. Okay, now if you try to interpret this right here, we will get the exponential function whose inverse is this right here, or this one. Check this out. A to what power will give us x, and it is saying m. So from this, we can get the exponential function, which will be a to the power m is giving us this x right here. Okay, so this is the exponential function whose inverse is this right here. I'll call this one equation 1. Then right from here, a to what power will give us y, and it is saying n. So the exponential function is going to be a to the power n is equal to y, and I'll call this equation 2. And guess what? We are trying to prove this right here. Inside the parentheses, we can see x multiplying y. We have x here, we have y here. This is not magic. Let's go ahead and then multiply the two equations. So I will just say equation 1 times equation 2. On the left-hand side, we will end up getting a to the power m multiplying a to the power n, which is this right here. And this is equal to x times y. Cool, huh? Now check this. We have the same basis and they are multiplying. If this happens, we can actually combine their exponents. So here, we will end up getting a to the power m plus n, and this is equal to x, y. Cool. Now we are trying to prove this right here. You see that we don't have exponent here. We don't have exponent here, right? We have this exponent, which is m plus n. Let's go ahead and then drop this exponent down by introducing log on each side of the equation. But to what base? What we are proving here is of base a. So let's go ahead and then introduce log in base a on each side. And if we do that, ladies and gentlemen, we have log base a of a to the power m plus n is equal to log base a of x, y. Now guess what? This right here, the power right here, we can move it all the way to the front here. And if we do that, we will end up getting, of course, let me get rid of this equation and then proceed from here. Cool. So we are going to have m plus n multiplying log base a of a, which is equal to log base a of x, y. Easy. Now check this. This right here is equal to 1. Why though? Check this. Log base a of a is equal to 1. Why is this true? It is true because a to what power will give us a? And obviously that is 1. A to the power 1 will give us a. So it is true. Cool. Now that we know this, let's go ahead and then proceed right from there. On the left-hand side, we'll be left with just m plus n, which is equal to log base a x, y. We are trying to prove this one, but now we have mn. But guess what? We have m here and then n here. Let's go ahead and then replace m with this right here and then n with this. And if we do that, finally, we are going to have log base a of x plus log base a of y. And this is giving us log base a x, y. And now we can see that this right here is exactly this. This is law 1. Okay, ladies and gentlemen, this right here is the law 2. Log base a of x minus log base a of y is giving us log base a of x divided by y. Why is this true? Let's also figure it out. Just as we did before, I'm going to set this right here to m. So we'll have log base a of x is equal to m Then this right here, I'm going to set it to n, which will be log base a of y is equal to n. And this time around, if I write a to the power m is equal to x, that is cool. Then from here, it is the same as a to the power n is equal to y, just as we know before. If this is our equation 1 and then this is our equation 2, looking at what we are proving here, x divided by y. We have x here, y here. Let's go ahead and then divide equation 1 by equation 2. Why not equation 2 divided by equation 1? This is because the x is a numerator here. So if we divide equation 2 by 1, that means we are going to have y over x, which is different from what we are trying to prove. Easy. So from here, we will end up getting a to the power m all divided by a to the power n. That is on the left-hand side. Then on the right-hand side, basically we have x divided by y. And check this out. We have the same basis and they are dividing. If this is the case, then we can subtract their powers. So on the left-hand side, we will end up getting a to the power m minus n. And this right here is the same as x over y. Cool. Now, just as we did previously, we don't have powers here, but here is the case we have power. Let's go ahead and then drop the power down by introducing log in base a, just as we did previously. And if we do that, we are going to have log base a of a to the power m minus n, and this is the same as log base a of x over y. And here we can move this power all the way to the front, and we are going to have m minus n log base a of a. Let me put this one in parentheses so that to be nice, then log base a of x over y. Now we now know that the whole of this is giving us just 1. So on the left hand side, we will have m minus n is equal to log base a of x over y. We know what n is. We also know what n is. They are all here. Let's go ahead and then replace them back so that if we do that, we will end up getting log base a of x minus log base a of y, and this is giving us log base a x over y, just as we have here. Log 3. All right, now this right here is the log 3. Let's check it out. Log base a of x to the power n is the same as n log base a x. That is, you can simply move this exponent or the power to the front right here. Why is this possible? When we were trying to prove law 1 and 2, we were using this law a lot. Let's figure it out why this is so. First things first, I'm going to set the whole of this to m. So we will have log base a of x is equal to m. And from definition of log, we can rewrite this as a to the power m is equal to x. Cool. Now we realize that here we have n, but we don't have n here. To bring this n, ladies and gentlemen, we are going to raise each side of the equation to the nth power, which will be this side to the power n, and then this side also to the power n. And on the left-hand side instead, we can rewrite this as a to the power m n, because we can multiply them from laws of indices. Great. And this is equal to, x to the power n. Now to drop these powers down, we have to introduce log on each side of the equation. Of course, base a. Cool. So here we will end up getting log base a right here. Then on this side, we are also going to have log base a. On the left-hand side of the equation, we are going to have m n log base a of a. And this is equal to, of course, from here, we are not rushing to drop this power down. Let's maintain it like that. So you have log base a of x to the power n. And obviously, this right here is just 1. So on the left-hand side, we have m times n is equal to log base a of x to the power n. We know what m is right from here. But before then, permit me to write this n first because multiplication is commutative. So I'll just have to put the n first. Then this m, I'm going to replace it with this, which will be log base a of x, and this is equal to log base a x to the power n. Now you realize that on the left hand side we have log base a x to the power n, but here we don't have that. This is found on the left hand side instead. So to make this one look exactly as what we have here, let's interchange their positions so that we will have log base a of x to the power n is equal to n log base a of x, and that is law 3, law 4. All right, this right here is the law 4. Like I said, stick to the video because at the end, I'm going to give you a particular law that will help you answer questions quickly. Let's look at it. Log base a of x is equal to log base b of x, all divided by log base b of a. You realize that on the right hand side, we have changed the base from a to base b. So this is known as change of base law. Why is this true? Let's figure it out. First things first, let's set the left hand side to m, which will be log base a of x is equal to m. And to get the exponential function from this one, is going to be a to the power m is equal to x. Easy. Now, we are trying to prove this right here with the base of b. Let's go ahead and then introduce log in base b on each side of the equation. And if we do that, we will end up getting log base b of a to the power m is equal to log base b of x. Then from law 3, we know that log of any base of a certain number to a power, we can move all the power to the front. So that here we will end up getting m log base b of a is equal to log base b of x. Remember, we are trying to prove this right here. So looking at this one, it is very necessary for us to divide each side of the equation by this number right here. So for here, I'm going to divide by log base b of a, then I will do the exact same thing right here. And we see that this and this one will go. On the left hand side, we have m is equal to log base b of x, all divided by log, let me rewrite this one well, all divided by log base b of a. But where from this m? Let's go ahead and then replace that with what we have here so that it will look exactly as what we have. Log base a of x is now log base b of x, all divided by log base b of a. And that is pretty much it. But guess what? There is an exception though. What if x is equal to b? What if this x right here is the same as the base that we want to change to? If that happens, then obviously we are going to have, so let me put this here, exception, okay? Exception is very, very important. So when x is equal to b, we're going to have log base a of b, and this is equal to, of course, we will have log base b of b, all divided by log base b of a. And we see that the whole of this right here will be 1. That is the exception. So I'm going to get rid of this one and then replace that with 1 so that the exception will be clear for us to see it. So here we are going to have only 1 divided by log base b of a. That is when x is equal to b. And ladies and gentlemen, these are the rules that we know in logarithm. Let's talk about the last rule that is going to help you out. And I'll give you an example for that. Even though I'm not going to prove that one, but it still works. So for the last one, I'm going to say bonus law. Yes, bonus law. If we have a to the power log base b of c, this right here is the same as c to the power log base b of a. We just have to interchange their positions, and that is pretty much it. Let's look at a question for this particular law. Let's say we have 5 to the power log base root 5 of 7, and we have to simplify this or evaluate this without using a calculator. This is where this law is very necessary. Using this law to solve this one, this is going to be, of course, we have to switch their positions. So we're going to have 7 to the power log base root 5 of 5. Even though the law ends here, but we are not done yet because we can simplify this further. Check this. We have 7 to the power log base root 5 of 5. But this 5 right here, I'm going to write it as square root of 5 or squared, so that when this cancel out this, we still be getting the 5 back. Cool. Then from law 3, we are saying that if you have a power right here, we can move it all the way to the front. So we will end up getting 7 to the power 2 multiplying log base root 5 of root 5. And we see that this right here is just 1. Cool. So ladies and gentlemen, we are going to have 7 to the second power, which is just 49. And that is pretty much it. Of course, I believe you found the video useful. Make sure you smash the subscribe button, tap on the bell notification. Let me know what you think in the comment section down below, and let me know the topic that you want me to walk you through in the comment section down below. See you again on the next video. Have a nice day. Until then, bye-bye.